Hello everyone, I Sandeep Bhatt, Assistant Professor, Department of Electronics and Telecommunication, Runta College of Engineering and Technology, Bhilai, affiliated to CSV2 Bhilai. I welcome you all on the course of Fundamental of Communication and its application. Today we are going to discuss the fundamental concept in communication system, that is modulation. Topic of our discussion is need of modulation and bandwidth requirement. Modulation is essential for efficient and effective transmission of signal over various distance and media. Our discussion will cover the need of modulation and the significance of modulation in ensuring effective communication. This lecture is divided into two parts, that is, the first one is need of modulation and the second one is bandwidth requirement. Understanding this concept is crucial for appreciating how modern communication technologies function efficiently and reliably. The main objective of this lecture is the first one, basic definition and the purpose of modulation. Second one is why modulation, and third one is effect of modulation on bandwidth of system. The basic definition of communication is exactly the exchange of information between source and destination. The key components of communication system is information source, modulator, transmitter, channel, receiver and demodulator. The basic characteristics of any communication system is it should be reliable, efficient and secure. The communication technology, if you see in a day-to-day life, that is the evolution of communication technology can be tracked back to the invention of telegraph in the 19th century, which allowed for transmission of message over a long distance using electrical signal. This was followed by the telephone, radio and television, which further revolutionized how information was shared and consumed. The advent of the internet in the late of 20th century marked a significant milestone, transforming communication by providing a platform for instant global connectivity. If you see in our day-to-day life, the technology which we use for communication, that is everyone know smartphone, mobile phones, radio, police walkie-talkie, wireless headphones, satellite communication, that is everyone know DTH, we have a DTH systems, space communication, all or know these NASA and this ISRO also send the signals daily on the basis of to the space. The television communication, that we know very well, the television communications, we daily watch the different programs through televisions, that is nothing through the communication. This technology cannot be complete without modulation. Communication technology is a dynamic and integral part of modern society. It continues to evolve, offering new opportunities and challenges. Undertaking and leveraging these technologies is essential for personal, professional and societal growth. Now, let us discuss about what exactly modulation. The definition of modulation is the modulation is the process of superimposing messages signal on the carrier signal. Modulation is the process of varying one or more properties of a signal called the carrier signal with a signal that typically contains information to be transmitted. The carrier signal is usually a high frequency signal, while the information signal, also known as the modulating signal, it is a low frequency signal that carries the actual information we want to send. What exactly the purpose of this modulation? By combining these two signals, we create a modulated signal which can be efficiently transmitted over a long distance. This combination allows us to overcome various limitations associated with direct transmission of the information signal. Now, what is the need of the modulation? The primary purpose of the modulation in communication system is to generate modulated signal as per characteristics of the channel. There are several benefits and application of modulation, such as first one, the antenna height reduction. The second one, avoid mixing of signal. The third one, long distance transmission. And the fourth one, multiplexing of signals. The fifth one, improve quality of reception. Sixth one, efficient use of bandwidth. And the last seventh one is the compatibility with transmission medium. Now, let us discuss about one by one the benefits of modulation techniques. The first benefit of modulation techniques is the antenna height reduction. To understand this concept, one should know about the basic fundamental of antenna. Antenna are a crucial component in wireless communication that is responsible for transmitting and receiving the electromagnetic waves. The size of antenna is directly related to the wavelength of signal it transmits or receives specifically. The optimal length of an antenna is typically a fraction, that is half or quarter of the wavelength of the signal. What exactly the relation of the wavelength and frequency? Now, let us discuss the relation between wavelength and frequency. Wavelength, that is nothing but the lambda, is inversely proportional to the frequency f. This relationship gives by the equation lambda equal to c by f, where c equal to the speed of light, that is 3 into 10 to the power 8 meter per second, and f is the baseband signal frequency, that is the frequency of the massive signal. To understand the antenna height, this concept, here we are considering two cases. That is case 1, in which if you would like to transmit a radio signal of 20 kilohertz, that is the message frequency as per discussed above formula, the height of antenna would be more than 3 kilometers. There is a formula which we use, that lambda equal to c by f. We use this formula, and if you put that the message frequency is 20 kilohertz and the constant of the quarter wave wavelength of the antenna, that you will find the antenna height is nearly 3 kilometer. This height of antenna is impracticable. We cannot construct such use of antenna, height of antenna. So, this is the first case that we can discuss here. Now, the case 2, let us consider the signal carrier of f equal to 100 megahertz, such as per formula the minimum antenna height would be 75 meter. Same we use here the same formula, where the frequency is more than the previous case 1. The height is practically possible, that is the such height of antenna can be constructed practically, and by considering both cases, it is observed that using modulation we can transmit a low frequency information signal over a high frequency carrier. Here we modulate the signal using carrier signal, hereby reducing the physical size of antenna, that is required size of the antenna we can achieve here. This principle is essential in the applications where space, size are constant, such as in mobile phone, satellite communication and IoT wearable devices, where we find these devices are small in size and handy. So, to implement such kind of the size of antenna would not be possible without this modulation. Due to this modulation, it can be feasible to install the less or the required size of antenna into the system. Modulation play a vital role in reducing the size of antenna by enabling the use of high frequency carrier waves. This reduction is vital for development and functionality of various wireless communication systems. Understanding the relationship between modulation and the antenna size help us appreciate the technological advancement that make modern communication devices possible. Now, let us discuss the second benefit of modulation is avoid mixing of signals. Effective communication requires clear and distinct transmission of signal, and modulation play a critical role in achieving this goal. What exactly signal mixing? Signal mixing, also known as interference, occurs when two or more signal overlap, leading to the distortion of the or loss of the intended information. This can result in a reduction signal clarity, increase in noise and potentially miscommunication. So, we can understand here what exactly the signal mixing, that is the mixing of signal is nothing but overlapping of signal. What exactly the importance of avoiding signal in communication. Avoiding signal mixing ensure that each transmitted message is received clearly and accurately, maintaining the integrity of information. This will help the clarity and maintaining the of signal. Efficient use of bandwidth. Proper modulation techniques allow for efficient use of the available bandwidth, preventing overlap and interference. Then the quality of service. In application like radio broadcasting, television, transmission and mobile communication, avoiding signal mixer is crucial for maintaining a high quality of service. How modulation play an important role in avoid of mixing signal? There are several ways in which modulation helps avoid of mixing. The frequency separation. By using different frequencies for different signals, modulation ensure that each signal occupies a distinct part of spectrum. This frequency division multiple axis, that is FDM, effectively prevent the overlap of signal. Bandwidth management. Bandwidth management, that is the modulation allows for precise control over a bandwidth. Each signal occupies techniques such as amplitude modulation, that is AM, frequency modulation, that is FM, and phase modulation, that is PM, ensure that signal remain within their allocated bandwidth, reducing the risk of interference. Signal isolation. Modulation techniques like OFDM, that is orthogonal frequency division multiplexing, create an orthogonal signal that do not interfere with each other. This is particularly useful in complex communication system, where multiple signals need to coexist without mixing. The third benefit of modulation is long distance transmission. Here, exploring the critical role of modulation in enabling long distance transmission of signal. Effective communication over a vast distance rely heavily on modulation techniques to ensure clarity, efficiency and reliability. Modulation helps maintain signal strength and integrity over long distances, preventing signal degradation and loss. Signal attenuation or the steady reduction of signal power as it propagates across a medium prevents low frequency signal from successfully traveling long distance. Attenuation is particularly noticeable at lower frequencies, leading these signals to decreases dramatically with the time and rendering them unsuitable for long distance transmission. Attenuation has decreasing effect as the signal frequency increases. This attenuation is directly we can see if the distance is increases, the signal get attenuated over a long distance. Higher frequency signals can sustain their strain over longer distance, making them better suited for long distance communication. This is especially significant in communication system, where signal fidelity at long distance is critical. Modulation is essential for increasing communication range, that it involves superimposing a low frequency signal on high frequency carrier waves. This procedure not only reduces the size of antenna used for transmission, but it also enhances the frequency of the sent signal. Modulation permits the signal to travel greater distance with less attenuation, increasing the overall efficiency and dependability of communication system. Thus, modulation is critical for long distance communication because it uses higher frequencies to reduce attenuation effect, allowing message to be carried successfully across a long distance. The next benefit of modulation is, that is fourth one, the benefit is multiplexing of signals. Multiplexing allow for the simultaneous transmission of multiple signals over a single communication channel, greatly improving the efficiency of data transmission. This technique is made possible due to modulation. What exactly the multiplexing? Multiplexing is a process of combining multiple signals for transmission over a single medium. A multiplexer is generally we call mux. At the transmitting end, merge the signal, while the demultiplexer, that is nothing but a demux, at the receiving end, that is separate them. Multiplexing enable multiple signals to be transmitted simultaneously over a single communication line, effectively allowing the same channel to carry various signals. This capability ensures that numerous TV channels can utilize the same frequency range without interference or overlap. As the result, different frequency signals can be transmitted concurrently, maximizing the efficiency of the communication medium. There are different types of multiplexing, including time division multiplexing, that is TDM, and frequency division multiplexing, that is FDM. Understanding the different type of the multiplexing and their application help us appreciate the complexity and sophistication of our communication network. The fifth benefit of modulation is improve quality of reception. Modulation plays a vital role in enhancing the quality of signal reception. By selecting the appropriate modulation techniques, we can achieve efficient, reliable, and high quality communication across various media. Understanding this principle is essential for anyone involved in telecommunication and signal processing. Digital communication system increases reception quality by modulating noise to reduce its influence. Modulation increases signal strength and makes it less susceptible to the interference, resulting in the crisper transmission. Techniques such as frequency modulation, that is FM, naturally minimize noise, resulting in more reliable transmission. That is why in daily life we use this frequency modulation for listening the quality of songs. Modulation increases reception quality by reducing redundancies and improving the signal prior to the transmission. That is where we find the any kind of system or any kind of signal when we transmit, if the signal system is not reliable, if the signal systems or the modulating the techniques whatever we use here, if it is not the reliable, we cannot confirm or we just cannot confirm the system that is used without modulation. So, to improve the signal, that is using modulation, that is necessary. The sixth benefit of modulation is efficient use of bandwidth. This is our second part of this presentation. Here we are going to explore how modulation techniques contribute to the efficient use of bandwidth in communication system. Understanding this principle is essential for optimizing our data transmission capability. Here we can use the any kind of system where we need a data. In daily life we use internet. In internet we require data, and the speed of internet is completely depends on the bandwidth of the system. This could be achieved with the help of modulation. Now, what is the importance of bandwidth efficiency in communication? The bandwidth efficiency, that is measured in bits per hertz, indicates how effectively a given bandwidth is utilized to transmit data. Higher efficiency means more data can be transmitted within a specific bandwidth, improving overall system performance. Modulation is a technique that allows for the transmission of multiple signals simultaneously within the same bandwidth by modulating them onto different carrier frequencies. This process involves varying a carrier signal in order to transmit information. The primary types of modulation includes amplitude modulation, that is AM, frequency modulation, that is FM, and phase modulation, that is PM, which can be used to carry different signal over the same communication channel. By assigning different carrier frequencies to the each signal, they can coexist in the same bandwidth without interference. Now, let us discuss about various modulation techniques and their bandwidth. The first one is amplitude modulation. The bandwidth requirement is 2 times the maximum frequency of baseband signal, that is nothing but a twice of FM. Here FM is the frequency of modulating signal, that is baseband signal which we want to transmit. The uses of amplitude modulation is simple but less bandwidth efficient compared to other methods. The second one is SSB, single sideband modulation. The bandwidth requirement, that is equal to the maximum frequency of the baseband signal, that is nothing but that is equal to FM. FM is again the message signal which we want to transmit. The advantage of this SSB is eliminates the redundant sidebands, making it more bandwidth efficient than amplitude modulation. Then third one is frequency modulation. In frequency modulation, it requires the larger than the amplitude but provide better noise immunity and fidelity. Here we can see the amplitude modulation, the SSB modulation and frequency modulation, where the frequency modulation required larger bandwidth as compared to amplitude modulation, but it having the importance, it having the main characteristics that it is you will find the better noise free system. The application of frequency modulation we know very well in daily life we use for the listening the songs. It is also widely used in high fidelity broadcast application. The next modulation techniques is phase modulation techniques. The bandwidth required for the phase modulation system that is equal to the FM. It provides the robust noise immunity. The application of phase modulation that is used in digital communication. The next modulation is quadrature amplitude modulation. This is one of the part of amplitude modulation. The bandwidth requirement for the system is effectively combine amplitude and phase modulation. The advantage of the QAM is its high spectral efficiency, making it suitable for high data rate applications such as Wi-Fi and digital TV. Hence, modulation techniques are crucial for the efficient use of bandwidth in the communication system. By choosing an appropriate modulation method, we can maximize data transmission capabilities while ensuring robust and reliable communication. Here, the modulation techniques play a very important role in the bandwidth, that is how we can save the bandwidth and increase the bandwidth with the help of modulation. Then the last and seventh benefit of modulation is the capability with the transmission medium. The modulation techniques is compatible with the different transmission medium such as the twisted wire, coaxial wire. Then there are two types of system. One is a guided medium and another is an unguided medium. Every transmission medium has its own special quality and restrictions. In order to ensure effective and dependable transmission, the modulation techniques modifies signal to fit the characteristics of the transmission medium, where messages are sent by copper wire, fiber optic cable or wireless modulation techniques. Here we know very well nowadays the fiber optic cables are playing a very important role at our home, which we find the broadcast or the broadband communication, that is we use internet service. The modulation techniques optimize transmission efficiency by the customizing signal to fit their particular medium. Importance of transmission media. The transmission media are the physical pathway that carry data from one device to another. They can be broadly categorized into guided media, that is twisted pair cables, coaxial cable, optical fibers, and unguided media, that is radio waves, microwave, infrared. Let us discuss about in the details. Guided media, also known as wired media, involve physical transmission path for signal propagation. The three primary types are twisted pair cable, coaxial cable and optical fiber. Twisted pair cable. Twisted pair cables, it is nothing but the copper wire twisted together. The types are unshielded and shielded pair. The application of the twisted pair cable generally use telephone and local area network system. The advantages: this gives the inexpensive, easy to install and sufficient for short distance communication. The coaxial cable comprise a central conductor, insulating layers, metallic shield and outer cover. This kind of coaxial cable generally we daily find in our daily life, which we use in a television communications for long distance systems. The advantage of these coaxial cables are the better noise immunity and higher bandwidth compared to twisted pair cables. The third one is the optical fiber cable. The optical fiber cable nowadays we find it is very important, that is having a very high bandwidth which we use in a internet communication. The extremely high bandwidth, that is low attenuation with immunity to electromagnetic interference. Unguided media or wireless media transmit signal without physical connection using electromagnetic waves. There are two types of waves: radio waves, that is we use in a daily life, in that we know Wi-Fi systems, and Bluetooth. Analog modulation techniques which you find here: amplitude modulation, frequency modulation, phase modulation. The digital modulation techniques are phase shift keying, quarter amplitude modulations. The optical modulation techniques are on-off keying, that is nothing but OOK, and phase modulation. The enhancing capability through modulation, that is the impedance matching, that is the first priority, and noise immunity is the second priority. Now let us discuss about the different type of modulation techniques which we already covered. Now let us take a snap, that is analog modulation, amplitude modulation, frequency modulation, phase modulation. In digital modulation, that is amplitude shift keying modulation, frequency shift keying modulation, quarter amplitude modulation, pulse modulation, that is pulse amplitude modulation, pulse width modulation, pulse position modulation. The importance of modulations that we already discussed, the main benefit of these systems are efficient utilization of available bandwidths, reduction of effect of noise and interference, enhancing multiplexing, and can be transmitted over the same channel. Let us summarize and conclude this lecture, as we have discussed about the communication systems and their key components, how modulation is primarily playing important roles in system, the benefits of modulation, bandwidth requirement, and essential techniques to make the communication better. In short, we also learned about the different type of modulation techniques, and it is clear from the summary of this lecture, modulation is indispensable in modern communication system. It enables the efficient and reliable transmissions of the information across various media, making it the cornerstone of the telecommunication and data communication. Understanding the principle and application of modulation is essential for anyone involved in the field of communication. Thank you for listening this lecture.